Welcome to video number 2 for the non-right triangle trig, law of sines and law of cosines. Please recollect that these are the two that we were talking about, law of sines and law of cosines. And hopefully you've had a chance to copy those down, work the other two examples with me on the previous video. And now we're just going to go through 3 more examples and call her a night. So again, we do have the situation where S represents side and A represents angles. So we have 2 cases to use these for each. One where we have angle, angle, side, and angle, side, angle, which means the side is sandwiched between this. The case would be given the measure of angle A, given the side B, and then the measure of angle C. And that would be sandwiched between those two. Otherwise, where we have a side-side angle situation, we have a side angle side and side 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 will be the 2 cases where we use law of cosines. Now we're not going to be experts after this, but we're going to know what to do and how to do that. So let's go ahead and continue with some examples. The final example for law of sines is the following. Given side A is 34, side B is 26, and the measure of angle B is 36. So what we have here is a side-side angle, which again constitutes us using the law of sines. Now how does this work? Well, again, we're looking at finding angles and sides, the missing 3 pieces. Now I have been given a angle B and a side B, so I'm ready to jump right into my law of sines. But notice I have a length here. So in this case, rather than the preceding 2, I'm going to put my unknown on top. In this case, the unknown is the sine of A. Now I'm given it over A, and that will equal my sine of B over B, side B. So sine A is what I'm looking for. I do have the side A, which is 34 inches. I have then the sine of B, which is 36 degrees, and the side B, which is 26 inches. Now again, what's really nice about having the unknown on top is that we can just cross multiply with the 34. Now, as I work that out in my calculator, punching in sine of 36 degrees times 34, and then dividing by 26, as that is done properly, we'll find out that we have sine A equal to a decimal value of 7 or 0.76864. And now what we need to do is we need to solve for A, where we want the measure of angle A. To do that, we're going to take the inverse of sine. So second sine on your calculator, and then type in 0.76864, or you can do second sine and then second answer, and it won't round that decimal, which is actually a little bit more precise. In doing this, I find out that the measure of angle A will equal 50.23 degrees. Now, I'm going to find out the other values that are missing. In this case, I now have my second angle, and whenever we have 2 angles, we'll just get the third angle, the measure of angle C, by simply taking 180 and once again subtracting the 36 degrees and subtract the 50.23 degrees. And as we work that out, we find out that the measure of angle C is a rather large angle. It's 93.77 degrees. So I've got 2 of my unknowns. The last unknown that I need to find then is the side of C. So when I'm going to do the side of C, I put my unknown on top. I now know that it is over sine C. Well, that is 93.77 degrees. and that will equal then my, let's see, 26 for side B over sine B, which is 36 degrees. Once again, I will just cross multiply, giving me 26 times, and start punching that in your calculator, 26 times sine of 93.77 degrees all over sine of 36 degrees, or meaning 26 times sine of 93.77 divided by sine of 36 degrees. And I will find my side C equaling 44.14 inches. Now we will be using the law of cosines, and the law of cosines is a little bit more complex as we've seen, but we'll work this out. Again, we're going to use a triangle just as a reference. Notice again, side C is based on little c, and the angle C right here would be the capital letter C. Now, what do we have? We're going to find the remaining sides. Now notice that they give us angle A, they give us side C of 15 and B of 20 kilometers. Now, because we have the angle A, we are going to have the cosine of 50 degrees. Now that is going to be one part of our function, which means on the other side of the equal sign, I will have my A squared. So that is what I'm going to solve for. Now, if I use the formula, it says then I should put my B squared plus my C squared and subtract 2BC cosine A. So now we've been given cosine A, so I know one of the things to substitute in. In fact, I know three things I can substitute. So doing the substitution, I have no substitution for A, or side A, but I do have the following. So I have 15 in for my B, which I will square. That is my C. So I'm going to put these in the same order as you see them. So 20 squared plus 15 squared minus 2 times 20 times 15 times cosine of 50 degrees. In simplifying this, or working out the simplification process, I ended up with 400 plus 225 minus 600 times cosine of 50. I could have already punched all of this in my calculator, but I'm going to do so now. So go ahead and type in 400 plus 225, then subtract from it 600 times cosine of 50. And when you do that, you will end up with 239.3274 as a value. Now I need to square root both sides, and I get a, and then when I square root the other side here, the right side, I end up with the following value of 15.47. Now I'm working with kilometers, so I have my third side in kilometers. Now when I go to get the other two pieces of information, which in this case are angles, I'm going to switch over and use law of sines again. That's just a little bit easier and quicker to use than this complex function. That function is not that complex. Well, thank you, Arnold, but I think it is, and we're all getting a little bit nervous about it, but it will be easier as we do more problems. So let's go ahead and see how we work with the law of sines now. Now I'm given three sides, but the only angle I have is A. So I'm going to use that A in this process. So if I want to find the sine of C, I'm going to put sine C over its side value of 15 and set that equal to my sine A, which is 50 degrees, which is all over my A value, which is 15.47. Now, as I worked on this problem, I will cross multiply, giving me sine C of 15 times sine of 50 degrees divided by 15.47. So I'm going to quickly punch that in, giving me the value of 0.74277. Now if I take the inverse of that, I'm left with the value of that the measure of angle C is 47.97 degrees. Now all we need to do is get the measure of angle B, which is found by 180 degrees, subtract my 47.97 degrees and the 50 degrees. And what that will leave me with then is 82.03 degrees. You'll notice in this last example we have side, 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 which again is the law of cosines. And working the law of cosines, we have to determine which one to start with. Well, we will always, as a point of note, start with the largest side, because the largest side has opposite of it the largest angle. So the largest angle of this problem will be angle A. So if that's true, I will take A squared, I will set it up as B squared plus C squared minus my 2BC. Again, notice these two match those, and have cosine of A. But this time it is cosine of A that I will be finding. So I do my substitution, and I'll have 64 squared equals 55 squared plus 59 squared minus 2 times 55 times 59 cosine A. Again, remember, we're going to solve for that A. So my next step, I find I have 4,096 on the left side of the equation. I have a 6,506 when I put these two together, and that is all subtract 6,490 cosine A. I'll bring this to the other side, and that will leave me with a negative 200 or 2,410 equal to negative 6,490 cosine A. Divide by this value of negative 6,490, I will end up with a 0.37134, which equals cosine A. So I'm ready to do my inverse. So cosine inverse of that 0.37134 will give me my measure of angle A. That gave me 68.2 degrees. So there's my measure of angle A. Once I have that, I am ready to begin doing my law of sines. Now my law of sines, I'm going to always take the largest two, try to find that. So I am going to work with my next angle. So I want sine C. And to find sine C, I am going to have sine C over 59 equals, and in this case I found A, so I'll have my sine of A, which is 68.2 degrees, all over its value of its side of 64. If we complete the process of sine C equals sine of 68.2 times our 59 over 64, we'll get a decimal value, and I'll leave that to you, but you should get that the measure of angle C equals 58.87. Check it out. If you have issues, see me tomorrow.